different numbers. So let's think about the factors of like the number 12. 12 has several factors. 1, 3. 3 goes into 12. 4 goes into 12. 6 goes into 12. 2. 12 goes into 12. All of those are factors of 6 because you can multiply that number times another number and get 12. So when we think about factors, we're thinking about numbers that go into other numbers evenly out of that. So it's a part of a multiplication problem. So when we're doing factoring, if you know your multiplication tables, you're going to be a lot better at this than if you don't know your multiplication tables. So if you don't know your multiplication tables, at least to the 12s, up to 12 times 12, you need to work on those. Get the app on your phone and just go through it 5 minutes a day. You'll have them memorized in a week. So if you don't know your multiplication tables, it's going to be very, very important that you learn them because it's going to make this job, what we're doing from here for the next 3 weeks, probably. If you don't know your multiplication tables, you're going to struggle with this. So you've got to know those to help you get there. So what we're going to be doing today is factoring using a greatest common factor. And what we want to be thinking about today is like reverse distributive property. We spent a good bit of time the last week, or well, technically 2 weeks if you count the part of a week we came, doing a lot of distributive property work, doing the multiplication out of that. So what we're going to be doing now is the reverse of that. We're going to pull out greatest common factors. So when you're factoring, and that's going to be what we're doing for the next long little while. When you're factoring, the first thing that you want to do before you even start working the problem is put the polynomial in descending order. Descending order means biggest exponent first. Down to the smallest. So if it's got an x squared and a plain x, the x squared needs to be in the front. Okay, so descending order first. That's going to make things easier for us when we're factoring throughout the whole unit of factoring that we're going to be doing. So make sure that polynomial is in descending order. Remember we wrote our answers when we were adding, subtracting, and multiplying polynomials. We tried to write our answers in descending order. So if we can start with the polynomial in descending order before we do anything, then that's going to help us be able to factor in more of a systematic way of going. So descending order before we do anything else. Okay. The second thing we're going to do, and this is going to be we're going to add to these as we go through the unit. So we're always going to start by putting in descending order. The second thing we're going to look for is find the GCF, greatest common factor. And factor it out. Okay. This is that reverse distributive property thing. That's the second thing you're always going to do if you're asked to factor a polynomial. First thing you're going to do is put it in descending order. The second thing you're going to do is look for a greatest common factor. Okay, greatest common factor is what we're going to do next. Folks that have a Chromebook on your desk, please close them. No need for those to be open. If you're charging your phone, you're not supposed to be charging your phone here anyway. Okay, so just close it. All right, now let's look at finding GCFs and factoring polynomials by GCF. All we're going to do today is GCFs. That's the beginning of everything. GCF will be a part of every step we take for the next 2, possibly 3 weeks. Okay, so Example A, we want to factor using GCF. Okay, let's start with something pretty easy. 3x plus 9. Okay, we look at that and we say, okay, first thing I want to check is it in descending order? What's the biggest exponent on the variable for this problem? Exponent. 1 is on the x, right?
Yes.
So the first term has x to the first power. The second term doesn't even have an x, right? So this one is already in descending order. We don't have to move anything around, okay? So if it's already in descending order, you're ready to look for the greatest common factor. And what we're looking for is what do these two pieces have in common? We got 3x and 9. 3 goes into itself. 3 also goes into 9. So that tells me, okay, there's nothing bigger than 3 that goes into 3, right? So that's the biggest thing. That's the greatest common factor is 3. Do both of them have an x? No, just the first one. So the greatest common factor is only the number 3. So we're going to pull the number 3 out, and then we're going to put some parentheses there. It's like reverse distributive property. If I pull the 3 out, what times 3 got me 3x? 1x, right? What times a 3 would get me a 9? 3. And it's a plus 3 because that's a positive. See how that's reverse distributive property? If we just redistributed the 3, 3 times x is 3x, 3 times 3 is 9. So that's factoring the GCF using reverse distributive property. That's kind of the thinking we want to do today. Okay. Let's try another one. 4x minus 12. Also very simple one, but it gets us started thinking about greatest common factors. Is that one in descending order? Yeah, you got the x part in the front and the plain number in the back. So that's in the right order. And the next thing we want to do is look to see, okay, what numbers go into 4 that also go into 12? 4 goes into itself. It also goes into 12. But does 2 goes into 4, doesn't it?
Yeah.
Does 2 go into 12?
Yeah.
Okay, why am I going to pick 4 and not 2? It's greater. It's bigger. We're going to pick the biggest one out of that. We won't pick 2 because it's smaller than 4. Okay? So we pick the greatest common factor is 4. What would that leave in the parentheses for that one? X minus 3. Because what times 4 gives me 4x? X. What times 4 gives me the minus 12? That'd be a minus 3. Okay? So it's taking distributive property, working it backwards through that greatest common factor. This is not bad. And say we had 12x plus 8x squared. Is that one in the right order? No, because x squared, that's a higher exponent, so it needs to be in the front. So we're going to rearrange it. Just swap the order. That's a positive 8x squared. That's a positive 12x. So just change the order there. Okay. Then we look at it and say, okay, what do 8 and 12 have in common? 4 goes into both of them. 2 goes into both of them. 8 goes into itself, but does it go into 12 evenly? No. So the biggest factor that goes into 8 and 12 would be 4. What else do they have in common? They both have the x. How many do they have in common? This guy's got 2 x's. The second one has only got 1. So what's the most that they have in common? Not together. 1 in common. This guy has 2. This guy has 1. Then they can only have 1 in common. So the greatest number that they could match up. So the GCF for this one would be 4x. Because they both have x's. So we can pull that x. 4 goes into both of them. What times 4x gives me 8x squared? 2. And I need another x because it needs to be x squared, right? So what times x gives me x squared? Another x. What times 4x will give me a plus 12x? Just a 3. Good job, Logan. 4x, parentheses, 2x plus 3. The way you can check to make sure you got the greatest common factor is if you pull the number out, look at what's left. Do 2 and 3 have anything in common? 1's the only thing, and that's not, that ain't gonna help us any. Okay, so always look at what's left and say, hey, do they have anything in common? If they do, then you didn't get the GCF. You got to start back over. Let's say we had 16x cubed plus 24x squared. Do we have to move it around? No, we got cubed in the front, squared in the back. 3 is bigger than 2, so that's in descending order. It's in the right order. Now we got to look for, when the numbers get bigger, there's a lot more options, right? So let's look at the factors of 16. Always start with your smaller number and think about its factors. 4 goes into 16. Does 4 go into 24? Yes. Is that the GCF? No. Why not? Because 8 goes into 16 and 8 also goes into 24, and that's bigger than 4. So 8's going to be our number. Why is 16 not a number? Not because of that. Why can I not use 16 as a GCF? Because it can't go into 24. It's a bigger factor of 16, but it doesn't go into 24 evenly. 8's the biggest one that goes into both of them. So I'm going to pull an 8. What else do they have in common? How many of them? The first one has 3. The second one has 2. How many could they pair up? I could only match up 2 of them, right? So there's an x squared in common. Because the first one has 3, the second one has 2. This 2 can only pair up with 2 of those, right? So that means that has to be the biggest number of x's that can come out. It's normally going to be that smaller piece there with the x, with the variables. The variables, it's always going to be the smallest amount that you have. Okay. So 8x squared, what would be left in the parentheses? 2x plus, be a positive 3 because 8 times positive 3 gives me positive 24. And then I don't need another x there because I've already got both of them out here. Another one here. Negative 22x squared plus 7x cubed. Is it in the right order? No, I got to rearrange it. So how do I rewrite it? Okay, I could write plus negative 22x squared, or I could just write minus 22x squared. Those are both the same thing. I prefer this way just because it's less writing and it's less complicated looking. Okay. Now, 7 and 22, what do they have in common? Let's think about what are the factors of 7? 1 and 2. 2 doesn't go into 7 either. 1 and 0. 0 doesn't go into anything. 1 and 7. It's prime, right? So 1 in itself. So does 7 go into 22 evenly? No. If it were 21, it'd work great, but it doesn't. So 1 doesn't help us as a common factor. 7 won't go into both of them. It just goes into the first one. So our number, we don't pull a number out. What else do these two have in common? They both got x's. How many? They both got 2. The first one has 3. The second one has 2. We're going to pull 2 of them out. So it's x squared is all that the GCF is. What's that leave in the parentheses? 7 minus 22. Sign's not changing there. We'll get into some in a little bit where we got to do some sign work, but right now, GCF on this one was just variables. Didn't have a number that went with it. Sometimes that happens. 15x to the fourth minus 20x. Is that in the right? Is it in the right order, Robert? I missed what you said. Yes, it is. Good job. Now, 15 and 20. Five goes into 15 3 times, and 5 goes into 20 4 times. Is there anything bigger that goes into 15? 15 does, but it doesn't go into 20, right? We know that. So 5 is our biggest number. How many x's do they have in common? 1, because this one's got 4, and the other guy's only got 1. Remember, always going to pick the smallest number of x's, or whatever variable they give us. So this is going to be 5x, and then what's it leave in the parentheses? What times 5 will give me 15? 3. And I used 1x out here, so how many do I need there, Kay? X to the third, good job. And then minus 4, does it need any x's? No, because I've already used this one out here. All right. Scroll back up. We can still see that one. Let's do this one. Negative 32 x cubed plus 24 x to the fifth. Just kind of mixing it in here. Is that one in the right order? No. So what do? Switch them. Okay. So what's the right order then? 24x to the fifth minus 32x to the third. Okay, so bigger numbers here, not huge numbers, but they've got a lot of options. 24's got a lot of numbers that go into it. 32's got a lot of numbers that go into it. 4 does go into both of them, that's true. Is it the biggest? 8 goes into 24 how many times? 3 times. How many times does 8 go into 32? 4 times. So that 4 and 3 don't have anything in common. So I know 8's the biggest that goes into both of those. So I know an 8 is going to go on the outside. How many x's come out? 3. Take the smallest set of them. Now we just got to figure out what's left. A lot of folks can find what goes out here. It's what's left where people sometimes make mistakes. So what times 8 gets me 24? 3. How many x's do I need? I got 3 out here. There were 5 to begin with. So I only need 2 left. Okay. How many, what's this part then? Not how many. Minus 4. Does it need any x's? No. Not bad. Not bad at all. You guys are catching on good. Again, this is very important to everything we're going to do after this. All right, let's kind of step it up a little bit. It's a little cooler out there than I thought it was. I want to shut that door. Yeah, plus 3x minus 5x squared. All right. I'll get that copy down. All right. What's the first thing we check? Is it in the right order? Yes. Almost. Kind of, but not really. So we got the biggest part in front, but is this bigger than that? No. So we need to swap the order of just those 2 pieces to get it completely in descending order. So that's going to be 6x to the third minus 5x squared plus 3x. So this one has 3 pieces in it. So we've got to look at 3 things at the same time. Okay? And math is just a big, I think about factoring as just being big puzzles. It's kind of like a Rubik's Cube. When you're solving a Rubik's Cube, you can't just look at one side, you kind of look at other sides too.
Yeah.
While you're doing it. So here we're having to look at three sides at the same time. So what do all three of these have in common? They all have an X. Is there a number that goes into all three of them? One. 6 and 3 have something in common, right? But the 5 messes that one up.
Yeah.
And so 1 is the only number that goes into all of them, and they all have how many X's? They all have 1 in common because this first one has 3, the second one has 2, the third one has 1. We're always going to take the smallest set of them if everybody's got it. So we're going to pull an X out is all that we can pull out. Technically, that's the 1 on front of it, in the front of that X. Remember, it's understood to be there. But it doesn't really help us. So what's that leave? 6x to the second minus 5x plus 3. And that's it. And you factored the GCF out of that. Next week, we're going to learn how to do something else with this. But today, our main goal is just GCF. That's all we're going to do is GCF today. All day long. And then 28x squared minus 21x to the fourth plus 14x cubed. What do we need to do first, Tyler? Logan, can you help him out? Move the 14x cubed to the front. Is that right? Which one should be in the front? The negative 21, because it's got 4 x's, so it's bigger. So it's going to go to the front. It's not about the number in front. It's about the exponent on the variable. So the x to the fourth, so negative 21x to the fourth goes in the front. What should go next? The 14x cubed. And then the last piece would be the 28x squared. Now, look at that piece that's in the front. What's different about it compared to the other two? It's negative. Anytime the front term, when you get it in descending order, is negative, when you find the GCF, I want you to pull that negative with it. So let's find the GCF of 21, 14, and 28.
7.
All right, 7 goes into 14, and 21, and 28. Okay, is that the biggest one? 14 could go into 14, right? 14 goes into 28, so 2 out of 3. But 21, it doesn't go into it evenly. So 7's the biggest one we got. So when we pull that 7, because this one in front was negative, we're going to make a negative 7 out of it. Now we need to get the letters. How many do we pull?
3.
Got 4, 3, and 2. 2, smallest set. Remember, always going to pull the smallest set if everybody's got them. Right? So there's the x squared coming out. Here's where it gets a little bit more complicated because we pulled out a negative 7. What's it going to do to every sign? It's going to change it from what it is. So here, what times negative 7 gets me negative 21? Negative 3 would get me positive 21. So I need a positive 3 x squared. Because I need x squared to get back to x to the fourth. What times negative 7 would give me a positive 14? That's the negative 2x. And then what times negative 7 would give me a positive 24? That'd be a negative 4. So it changes the sign of everybody on the inside. If you pull a negative, and the only time you're going to do that is if the front piece is negative. Okay, if the front piece is negative, that's when you're going to do that. Let's do another one that's similar to that. Let's say we had negative 42x to the fourth plus 24x minus 48x squared. Yeah, I need to swap the order of the second two, right? That's what Tyler's saying. He said just swap the order of just the second two. The 42x to the fourth is in the right spot. The other two are messed up. So let's put those in the right spot. And then plus 24x. Okay? Now I'm doing GCF. So what's the GCF of 42, 48, and 24? 8 goes into 24 and 48, but 8 does not go into 42. 4 goes into 24, 4 goes into 48, 4 does not go into 42. 6 goes into 24, 6 goes into 48 8 times, 6 goes into 42
7 times.
7 times. So 6 works. Is that the biggest one?
Oh, 24.
Okay, 24 goes into itself, 24 goes into 48, but 24 can't go into 42 even.
12.
Okay, 12 goes into 24 twice, 48 3 times, or 4 times. 12 goes into 42, 3 and some change, so not even. So.
No, it's gotta be 6.
We tried 8 already.
Tried
6 is the next smallest, or next one that worked. So 6 is the right one. But when we're pulling that out, what do? Make it a -6 because this first term was a negative. So we're going to pull -6. And then how many letters do they have in common?
1.
I heard 2 different answers. 1. What's the smallest amount? 1. This guy's only got 1, so we're pulling that amount. So -6x. Okay. What times -6 will give me a -42? +7x to the third. If it had 4 to begin with and I took 1 out, that's 3 left. Okay. -6 times what will give me -48? 6 times how much? 8. +8. X. Well, I need it to be second when I multiply it out, but I've taken 1 out. There were 2 to begin with, so there's only 1 left. What times -6 gets me a +24? -4, good. And does it need any x's? No. There is the factored form of that. Okay, factoring by GCF. It's a skill that you've got to have as we move forward. So we've got to practice it and get good at it. What's the first thing you do to every problem? Make sure it's in descending order. That's going to be the rule, the first thing you do for the next 2 or 3 weeks. Probably for the almost the rest of the year for everything that we're doing. Everything we do after this relates back to factoring. So descending order, first thing. Then the next thing you look for is what? Find the GCF of whatever terms are in the problem, okay? Sometimes there's 3 terms. Most of the time it's just going to be 2 as we're just starting out today, okay? So we're going to get going with factoring today.
That was easy. For me.
If you know your multiplication tables, and Robert, you know yours, so that makes it easier. You don't know them, it's tough.
No problem.
Yes.